My name is Prasanna Vijayanathan. I lead and drive initiatives at Netflix that help understand how our applications perform for our users and provide insights on ways to improve them. This involves Netflix on the TV application, on our web platforms, uh, mobile devices like Android and iOS. I'm going to share my learnings with you all today that combines the worlds of performance of the application and the user experience with the help of AI-driven insights. So let's dive in. So let's think about the software application that you're building, typically running on phones, Androids, iOS, or the browser, or even on TV, maybe your multiverse, any kind of application. Any application that you build would have a purpose, a true north, if you will. What is the value add you're providing to your target audience or your users? And typically, when we think of values of an application, we want to see if users actually like using what we are building and what solutions we offer. And this can be understood through a variety of metrics, a good representation of the true north for your application or product. For example, it could be the time people spend on your application. Time spent on an application could be an indication of how well your application is performing for your users. It could be something like the quality of engagement that they have on the application, and other metrics of growth, like, for example, subscriber growth. All of these are indications of good values that we are adding from our application to our users. These metrics that we use to understand how our users feel about using our application add up to what we typically call user experience when they're using the application directly. And in order to make the experience of our users better, we try to understand how different parts of our applications operate and how our users like or dislike it. So, for example, if you look at a high-level view of a medium to large-scale application, might look something like this. And you have your application running, and your users are interacting with the client side of the application on the phone or laptop, TV, or whatever platform or devices. These applications will typically talk to backend services, could be monoliths like a single service or microservices, whatever floats your boat, through a load balancer that makes sure your infrastructure is not getting overloaded or overwhelmed with requests. And these services then receive requests from the client applications on what the users want to do with the application, and then respond to it based on the underlying data that is going to serve those requests. You might also employ like infrastructure optimizations, like using CDNs to make the applications faster for our users. So then comes the point, is the application doing what we intend it to do for our users? So performance engineering typically entails monitoring and observing the different states of the system of our application and the latencies involved. At this point, in order to understand what is working well or what is not for our users, we want to measure the performance of these different components. And we capture these states and latencies and send it to yet another service, usually called a tracking service, which will track the different states of the systems and give us the ability to understand if something is going wrong or not. That takes us to this next step of application performance, the foundation of all the data that we can use to measure and optimize the application. And this, combined with the user experience or the value add and the true north that we've defined for our application, together can provide powerful views and perspectives of the system. For example, a dashboard like this could tell you how many people have come and viewed your application or a particular page or a particular video and so on. But then combine this with the performance metrics we can look at for a particular metric. How did the number of views change? across different data centers that your application is being served out of. With all this powerful data, we can now understand what our users experience on our application and also why. So one way tech companies have been achieving this understanding of what our users like is through A/B testing or experimentation. What we typically do is test out different product offerings or features and see what our users like or dislike. And that will give us an idea of, hey, say I'm looking at how well users are engaged on product A versus product B. So based on the outcomes, we could figure out what version the majority of our users like and decide what version to keep and what not. Sometimes we may get the question, why? Why did most users like one version and not another? And knowing this helps us understand what is better for our users so we can keep improving our offerings. Sometimes the answer could be straightforward. We can look at a metric, say, like render time, and we could simply figure out the correlations that could explain those observations. For example, looks like product A has a consistently lower render time than product B. So maybe users like the fast rendering experience, and that is why they were more engaged with the application with version A than version B. But more often than not, as our applications become more complex, it is getting harder to find such clear correlations. Because as we add more complexity, we collect more and more metrics, and our users get more and more diverse. A lot of times, when we try to correlate a single metric, it might end up looking like this, where there's really no clear way of saying if render times really had an impact on product A versus product B. And also, if you want to look at the number of metrics that we've been adding for tracking and monitoring performance of our applications, this has been growing consistently through the years. And I'm not even exaggerating. This chart shows how many metrics Netflix uses from a blog back in 2014. I would only safely assume that this number has grown since then. On top of this, if you add in all the cardinalities from all the different dimensions that we've been tracking, think about all the thousands of different devices that we have in our ecosystem today, all over the world, and all the different network complexities that come in across regions, and most importantly, what our users need and what they prefer, has also been evolving at a drastic pace. Users have different personas and expectations from applications, and all of these diversity and preferences add up. Given all this diversity, it almost seems impossible to understand this growing gap between what our users expect and experience on the application and what they actually got from our application's performance. That brings me to my next active area of research, what I call perception of experience. I'll start with an example. Let's say we have two groups, like we saw earlier, two versions of our product A and B, and we are looking at a metric like render time. Typically, we aggregate these metrics across different dimensions, and then we compare them. We look at an aggregate like average. So let's consider a hypothetical scenario. Some experiment that we run reduce render times for two groups of users, A and B, without changing any other behavior on the app. We run this, collect the data, and on an average, one group gets about 200 milliseconds faster render times than the other group. So now if I ask, which group would you pick, A or B? What would you pick? Maybe you want to look at more aggregates. So let's look at the 50th percentile. I hope people are familiar with these aggregate metrics. Say this is the 50th percentile. Group A feels much faster than group B again. Say P90 at a much end of the tail. Group B is still much slower than group A, even at the tail. If I just present this data, people typically might think group A is better than group B. But really turned out group B likes their experience better. But why would this be? So if I show you a different kind of plot, like this one, maybe this chart makes it more evident. Even though Group A users have lesser render times than Group B users have been getting the same render time across all days. This is over like 30 days. Group A, however, had a high intra-period variation. That is, the experience on one day was very different from the next day. This takes me to this idea of consistency of QoE. And why is this important? To consider the quality of experience or QoE from a user's perspective. We had just looked at the aggregate metrics, we would have thought Group A would perform better than Group B and given that product often. But even though Group B users were getting a worse experience, it was consistent with what they were expecting. This is because, as we all intuitively understand, experience is relative. How you assess experience on an application could be very different from the next person. For example, if you're used to watching Netflix on a mobile device on a crappy network, you may be okay waiting for the video to load after you hit play for 5-10 seconds. But if the person next to you has a blazingly fast internet and watches it on their 100-inch home theater, they may not be as tolerant. Next, the consistency aspect. Right? If a user is used to an environment, they have an idea of what to expect from the app. It may not be specifically your application. It might just be their environment that impacts all the applications that they use. So they have an idea of what to expect. If they know that Netflix is going to take 5 or 10 seconds to start playing a video, they are prepared for it. If our application meets that expectation every time, then we may be good. And if we actually deliver something better, great. But if we deliver something worse, that's when users get frustrated. So then what we are doing now is saying building an application end to end, not just UI or UX design, but end to end application building from a user's perspective. Keeping the user at the center, we evolve our application to the user's needs and preferences, understand their experience, and adapt the application to their environment. And if we are able to personalize the application to every user's needs and preferences and their environment conditions, then we can keep their experience as consistent as possible, which means we can delight the user on the application as much as possible. What we are doing now is moving the bar for performance and user experience as close as possible to each other. But all that sounds good. How would we really know what users like and don't? That was our biggest challenge. So remember, we have a true north, some true north metric for user experience that we talked about, the value add that we provide to our users. We can use these true north metrics to understand or indicate when our users like an experience on the application or don't like one. When they are very happy with the value we are providing, or experience things that stop or delay them from using our application as they intended, these true north metrics would be able to point that out for us. And if we are able to do this for every user, every session, these metrics would show it to us. So how do we really do this? As the solution is to most things today, we turn to AI, some kind of modeling at least. The type of model would depend on the scale of data your application operates on. This can vary from simple logistic regressions or classification models to complex deep neural networks. My recommendation would be to start simply. Let's look at an example. The basic entities that you would need is an algorithm or model that understands the QoE or quality of experience signals, your user's devices, the network conditions, and their experience metrics. Measure of experience could be, say, the number of videos they watch in a session. Some people may watch 10 videos in one session, typically. Another might just watch one video for the day, and yet another may watch 100. The algorithm or the model will understand this behavior for each user and set a personalized baseline. So it would understand that this user on this device typically watches 5 videos in one session. And then we would continue monitoring what their experience is with the number of videos watched across sessions. The model then would correlate this with all the other environmental features and characteristics like devices, latencies over the network, render times, and so on, and all the other dimensions that we discussed earlier. And then when we ask the model and look at trends where we see a drop in the number of videos watched or an increase in the number of videos watched, we can ask the model what happened and why. And this technique is now getting popular, called model explainability or XAI. So what is model explainability? These are techniques for understanding and interpreting the predictions of a model, of artificial intelligence system or a machine learning model. This becomes important, especially while dealing with complex models like deep neural networks and making critical decisions based on the model's outputs. There are several techniques that we use here: simple feature importance ranking, SHAP values, line, other gradient-based methods, and so on. But all of these methods can answer the question, why? Why did a user experience a certain thing? For example, let's say we want to look at that one session where the videos watched for this user went down, and we want to know why. We would share this session information with the model and ask it to predict and stack rank its feature importance of that prediction. And it would give us something like this. It could tell us OOM crash, which stands for out of memory crash in this case, was the highest ranking feature for this prediction. And then you can see heap memory, cache size, all of these metrics related to a device memory, being like the top 3 most important features that the model used to predict a lower videos watched metric for this session. And going forward, we can do more amazing things because we can look at XAI or explainable AI and integrate them with natural language models. For example, the feature importance chart that we showed earlier could be converted to something in natural language like this, where it could tell us, hey, this feature, the highest contributing category is related to their device, and they had an OEM crash, and 3 out of the top 8 features contributed significantly to that. So think about how far we can take this. We can understand what a user experiences on the app every single session. We can also predict what they're going to experience next time and take corrective measures so they don't have to get there. Right? This is truly exciting to me, to integrate AI in real time, to adapt applications to the needs and preferences of every user for every session, or every time they interact with your application. That is really powerful. With that, if you want to take a peek into the future, think about what's possible. First of all, we want to be able to do this automatically and scale. Right? We want to have automatic feature selection and experimentation on the fly. Right? We can figure out if a particular configuration works well for a particular user on a particular device, and then automatically understand if it does or doesn't, and then change the configuration to what best works for them. And based on their disruption or satisfaction, we can determine if a feature should be delivered to them or not. Think about scaling this to an automatic experimentation platform. A/B testing that understands this for all of our users. We can use this for a lot of other things like bias identification, to see what are the biases in our application and what are the corrective actions that we need to take so that we give consistent experience for all our users. That leads me to another pet area that I've been exploring that I'm calling equitable engineering, where we understand the biases of our system and make sure all the applications that we build are always fair and provide equal opportunities for all users so that every user on every application gets the best experience possible every time. That's it from me. Thank you. And if you're interested in connecting and if you have more questions that you want to talk about, feel free to get in touch with me on LinkedIn. Thank you so much.